Whenever a new highway, a factory, or a dam gets proposed, there's this incredibly important process that kicks in to protect our environment, the environmental impact study. It's basically our way of asking a huge question before we even think about breaking ground. What are the real, long-term consequences going to be? So let's dive into how these studies actually get done.
At its core, every single one of these studies is wrestling with this one fundamental question, right? It's this incredible balancing act between progress and preservation. And if you're going to find that balance, you absolutely need a clear, methodical plan.
So, here's how we're going to break it all down. First, we'll look at the overall blueprint of the whole process. Then, we'll dig into 3 key phases. And finally, we'll see how all that raw scientific data gets turned into a clear, solid decision. The entire framework for these studies is built on a really systematic 10-step approach. You can think of it like a roadmap that guides a project all the way from just a simple idea to a fully monitored operation, with environmental checks at every single stage of the journey.
And that 10-step roadmap, it's neatly organized into 3 distinct phases. First up is the initial phase. That's all about planning and gathering information. Then you move into the impacts phase, which is where all the really heavy technical analysis happens. And it all wraps up with the decision-making phase, where the final choices are made. It's just a really logical flow from understanding the situation to taking action.
All right, let's jump into phase 1, the foundation. This is where an interdisciplinary team, we're talking experts from all different fields, gets all the basics right before any of the super complex analyses can even get started.
These first 4 steps are just crucial for laying a solid groundwork. First, you got to clearly define the project and exactly why it's needed. Simple enough. Then, you dig into all the relevant environmental laws and regulations, the official rulebook. After that, you brainstorm all the potential impacts. And finally, and this is so important, you create a detailed snapshot of the environment before the project. That gives you a vital baseline to measure everything against later.
And this isn't just guesswork. Not at all. To identify those potential impacts, teams use these really systematic tools, like something called the Leopold Matrix. I want you to imagine a giant grid that maps every single project activity, like, say, construction or water discharge, against every single part of the environment, like air quality or local wildlife. This forces everyone to consider every possible interaction, making sure nothing important gets overlooked.
So, with our foundation set, we can now move into phase 2. And this is where things get really technical. We're not just identifying potential impacts anymore, we're predicting their exact size and scale.
The heart of this phase is impact prediction. This is the moment we turn all those what-ifs into concrete numbers. Will the air quality change? Okay, but by how much? To get these answers, teams use everything from complex mathematical models and computer simulations to actual physical scale models in a lab.
Let's look at an example. Say for a new industrial project. This table shows us the baseline air quality. This is the environment without the project. You can see the current levels for a bunch of key pollutants, but I want you to pay close attention to that one in the middle. PM10 particulate matter. Right now it's sitting at 150 micrograms per cubic meter.
Okay, now, here are the predictions for the environment with the project up and running. You can see the changes pretty much across the board, but look at PM10. The models are predicting it's going to jump from 150 all the way up to 350. Wow, that is more than double the original level.
This chart really shows you the stark significance of that number. The jump from the baseline of 150 to the predicted 350 puts us exactly on the official government alert threshold. This is a major red flag, and it's precisely the kind of critical finding this whole impact prediction phase is designed to uncover.
So, we've predicted a pretty significant impact. What happens now? Well, that brings us to our final and most critical phase, making decisions, figuring out how to mitigate the harm, and then monitoring the long-term results.
The key concept here is mitigation. And this isn't just a single action. It's a strategic 5-tiered approach for dealing with the negative impacts we just quantified. Think of it as the official playbook for making a project as environmentally friendly as possible.
Now, these strategies are hierarchical, kind of like a ladder. The absolute best option is always number 1. Just avoid the impact completely, maybe by choosing a different location. If that's not possible, you try to minimize it, for example, by limiting noisy construction to certain hours. If some damage still happens, you then have to rectify it, like replanting trees that were cleared. After that, you try to reduce the impact over time through ongoing maintenance. And only as a last resort do you compensate for it, like by creating a brand new wetland to replace one that was lost forever.
So the final 3 steps wrap everything up. First, after weighing all the evidence and the mitigation plans, the decision makers select the proposed action. Then comes the enormous task of preparing the written documentation, that's the official environmental impact statement. And finally, a plan for long-term environmental monitoring is put in place to track if the predictions were right and if the mitigation is actually working.
So we have all this incredibly complex data, right? Like that 350 number for PM10, but how in the world do you communicate what that really means to the public or to decision makers who might not be scientists? Well, that's where some very specific communication tools come into play.
We use something called an environmental index, and its entire purpose is to take a huge amount of technical information and just boil it down into a simple score or a category that anyone can immediately understand. It basically translates complex science into a straightforward message.
This is the official Pollutant Standards Index, or PSI, and it's a perfect example. Just look at the column for our pollutant, PM10. You can see the index connects specific concentration levels to these really clear, understandable designations. As the numbers go up, the labels get more and more serious, from the standard to alert to warning and even emergency.
And remember that number our impact prediction calculated for that industrial project, 350?
So, by using the index, we can translate that number into something meaningful. 350 micrograms per cubic meter corresponds to an index value of 200. And what's the official designation for that value? Alert. All of a sudden, a complex data point becomes a simple, powerful warning that demands attention from everybody involved.
But as this quote from the source material reminds us, it's never just about the numbers. The data tells us what is likely to happen. But interpreting the significance of that change and deciding what level of risk is acceptable for a community, well, that requires human values and judgment.
Which really leaves us with the ultimate question, doesn't it? This whole process gives us the facts, the charts, the index scores. But at the end of the day, the decision of whether an impact is truly significant enough to change or even stop a project, that's a complex choice. It's a conversation that has to involve scientists, policymakers, and the public, all working together.